Here's sample test 3, problem number 6. A segment of wire carries a current of 25 amps along the x-axis from x equals -2 to x equals 0, and then along the y-axis from y equals 0 to y equals 3. In this region of space, the magnetic field is equal to 40 millitesla in a negative y direction. What is the magnitude and direction of the force on this bent segment of wire? Well, we know that the current is 25 amps. And if we were to describe this segment of wire as it's going from -2 to 0 and then from 0 to 3, that vector for that wire would be described as 2I plus 3J meters for its direction with the current. And then our magnetic field is 40 millitesla. So our magnetic field is actually in the negative y direction, so it's going to be a negative 0.04 J Tesla would be our magnetic field. And we know that the force is equal to I L cross B. So this is going to be equal to 25 times our L vector, which is 2I plus 3J, and that's going to be crossed with B, which is a negative 0.04 J. Let's put parentheses around that. Let's bring out the negative 0.04, so this is going to be 25 times a negative 0.04 times 2I crossed with J plus 3J crossed with J. Now J crossed with J is 0 for a cross product, and so we have the force is equal to negative 1.00 for the 25 times negative 0.04 times 2. Now I cross J, if we use our mnemonic device for IJK, going in the I cross J direction, we end up with vector K. So this is going to be equal to 2K for I cross J. So our force is equal to a negative 2K newtons, and that would be a vector force right there. So the magnitude of that force is 2 newtons. Its direction is in the negative K direction, which would be in the negative Z direction. That's one way to look at this problem. There's a slightly shorter way. If we think of force as being equal to, at least the magnitude of the force, ILB sine theta, and we look at these wire segments as two segments, 1 and 2, we can look at segment number 2, and there's a 180-degree angle between the direction of the current and the magnetic field, and the sine of 180 is 0. So there's going to be no contribution to the force from this second segment here. And the direction from the first segment, that angle is actually 9 degrees. And the sine of 90 is 1. So if we look at the force due to that first segment, we have a current, 25 amps, length of 2 meters, magnetic field of 0.04 Tesla, and we have an angle between the two directions of 9 degrees, which sine of 90 is 1. So the magnitude of this force is going to be 25 times 0.04, which is 1, times 2, which is 2 newtons. So there's the magnitude of our force, and the direction would be given by the right-hand rule. If you point in the direction of the first vector, which would be the positive x direction, the I direction, and you close on the second second vector, which is the negative j direction, your thumb of your right hand would be pointing into the page. So you would be going into the page, which is indeed the negative z direction or negative k direction. So that would be your direction based on that. So that's just a second way of doing this problem, just focusing in on the part of the segment that is causing a force.